What's up, people? Hey, we're on page 172. Welcome to 3-3 as we carry on in our function journey. Today, we're really going to be looking at initial values and rate of change, which one is greater, as well as we're going to keep looking at linear versus nonlinear functions. So a little bit old and a little bit new. Either way, here comes example number 1. Here we go, folks. See that?
Folks.
How can you compare two functions? Think about this question during the lesson.
Look at their rate of change and their initial value.
An auto assembly factory needs to purchase new welding robots.
Ooh.
The factory manager has information on two different models of welding robots. Notice that the welding rates are shown differently for each model. One model uses a table of data, while the other uses points on the line.
Okay.
How do the welding rates for the two robots compare?
Look for relationships.
What properties of functions can be used to compare functions?
So again, we're talking about welding rates or rate of change. So that means slope, or we should be thinking slope here. So can we find slope of a table and slope on a graph? I think so.
Both robots weld at a constant rate.
Yes, they do.
So you can use the initial value and the rate of change to compare the linear functions.
That's right. So initial value, guys, y-intercept, rate of change, right? We should start to get comfortable. Rate of change is a synonym for slope.
The first step is to find the welding rate, or the constant rate of change, for each robot.
Yep.
What does the constant rate of change for each robot mean?
Select your answer.
So what does the rate of change mean? So guys, take the y variable, put it over the x variable. So this many y variables for this many x variables. So this many welding tasks for this many minutes. So welding tasks per minute. I knew I'd get that right.
You can use any two rows of the table to determine the Model T1000 welding rate. Let's use the first two rows of data. The constant welding rate for the Model T1000 is 52 minus 20 and 8 tenths.
Yep.
Divided by 5 minus 2.
Y minus y, x minus x.
Per minute. The chart for the GNX 007 robot shows that for each minute of work, the robot completes 11 and 2 tenths tasks. It also shows that the rate is a constant.
Terrible numbers.
11 and 2 tenths tasks per minute.
Luckily, we didn't have to do anything with that.
The other way to compare the robots is to find the initial values. What is the initial value for each robot?
Guys,
select your answer.
When you think about initial value, right, where does this start? So at a time of 0, how many welding tasks have either of these robots done?
Well, if they ain't turned on, are they going to make any?
Yeah. Imagine before we turn the power on to the GNX 007, right? It doesn't have any tasks done, nor does the T1000. So yeah, their initial values or y-intercepts are both 0. Right? These are proportional.
The initial value for both robots is 0 tasks completed after 0 minutes.
Yep. This is true.
Now compare the two robots. They have the same initial value, so the better robot has the greater welding rate. The Model GNX 007 robot has a greater constant rate of change, or welding rate. It can complete more welding tasks per minute than the Model T1000 robot. Now you have two ways to compare linear functions.
That's right.
What are the two ways?
Well, we can look at rate of change or slope, and we can look at their initial values.
That's great.
Okay. Oh, wait a second, folks. We got a third robot.
What's this one called?
We don't. This is the Knoll 4000.
I thought it was called the RF.
No. This is the Knoll 4000.
RF 99.
It has
a great one. It's called.
Yeah. It has a welding rate, guys, and they give me an equation right here. Okay. W again is the number of welding tasks, and T, of course, is time. How does it compare to the other two? Well, so let's think about the other two robots. For starters, well, look at our initial value. right? What's my initial value for the, we're going to call this the null 4000x, okay?
How did you spell that?
That's null. Hold on, here we go. Null
No.
4000x. There you
No,
go.
No, still wrong.
So, all right. So initial value is identical, right? Because it's 0. So initial value 0, and that's identical to the other two robots, right? Remember, our other two robots were the T, I think 1000, and the GNX007. Okay.
They all had initial values.
This one I think had a
11.2.
11.2, and this one was 10.
10.4.
10.4. Okay. These were their. I'll just put on their M, right, for slope or rate of change. Okay. So now we just need to figure out what the third robot, the null 4000x, what its rate of change is. And they gave us an equation, so we should be pretty good at identifying slope, right? So it is 10.8.
Boy, that was tough.
Yeah, so 10.8 is the null 4000x robot. So it is, it can weld more than this, but less than this. So if you wanted to put some
Per minute.
yeah, if you want to put some inequalities on there, you could do that. If you didn't really want to, that would be okay. Okay, I think we're good there.
How can linear equations help you compare?
So guys, if we have a linear equation, right, that's probably the best case scenario because we already can easily identify slope and y-intercept, all right, from those.
Yes. Video number 2 on the
Bonus video!
Here we go.
A square with side length s is shown.
Here it is.
The table shows the relationship between the side length and perimeter
Okay.
as the side length increases from 0 inches
To 4.
to 4 inches.
Perimeter. Add them all up, goes around the figure.
The graph shows the relationship between the side lengths and area.
Ooh.
Notice that the graph increases.
Doesn't look like a straight line to me.
But it is not a straight line.
Wonder what we call not straight lines.
The table and the graph describe two relationships. How do the two relationships compare?
Well, they both start at 0, and they're both increasing. You know what I mean?
Are they both functions?
Let's look. So x's and y's don't have any repeating x's here. So yeah, each x value is paired up with exactly one y value. Same thing here. I can do my vertical line test. This is going to pass that. So yeah, I think both of these are functions. They have the same starting point, initial value. I wonder about their rate of change. Who knows?
First, analyze the table that compares side length and perimeter. Notice that as side length increases by 1, the perimeter increases by 4. This relation is a function. It has a constant rate of change. It is a linear function.
So guys, this is what we talked about the other day. How are my x values, right, going from one to the next to the next? Well, they're getting larger by 1, right? How is this changing? Well, this is also changing. It's increasing, and here it's getting larger by 4. Because these numbers are constant, right, this means it's going to be a linear function.
Then, analyze the graph that compares side length and area. This relation is a function, but it does not have a constant rate of change. It is a nonlinear function.
We knew that from the graph.
Both relationships are functions. Both the perimeter and area are functions of side length.
Yes, this is true. Okay, so guys, we're going to work a little bit more on when we have a table, how are we figuring out if it's linear or nonlinear, rate of change, and all that. But there we go. So example 2, we only got one more, unfortunately. Example 3. Here we go.
Two linear functions are represented below.
Yep.
Compare the properties of the two functions.
So again, we only have two properties we're looking at, gang. Rate of change, also known as slope, and the y-intercept, also known as the initial value or the starting quantity, okay? So we got two functions, function A, function B. This one's on a graph. This one's just merely an equation, right? And it just says compare the properties. So we want to say, hey, function A has this rate of change compared with function B's rate of change. Then we're going to look at the other property, right? The y-intercept or the initial value. Function A has this initial value compared with function B, which has this initial value. Sometimes they might want to know which one is greater, right? And that's what we're going to do. So in our equation here, again, we should be very good at this and very comfortable, right? My rate of change is 2, right? My initial value is not 3. It is not 3. It's negative 3, okay? On a graph, once again, my initial value, where does my graph start at? That's why we call this the starting quantity. Well, it starts up here at 7, right? We could find the slope of that line, identify two ordered pairs, do a little bit of y minus y over x minus x.
Oh, I love that.
Okay, we can find the rate of change or the slope, right, for the graph, right? They did that. They figured out it was 1/2, okay? There we go. So, again, I kind of talked you through everything. When they compare the properties, guys, here's what they want to know. Function A has a greater rate of change. 2 compared with negative 1/2, okay? Function A is greater. Function B has a greater initial value, 7 compared with negative 3. Okay, everybody good on that? Here's a kicker. What if this rate of change was negative 5? What if the rate of change here, guys, was negative 5? Right? And this rate of change is the same too. Which one is greater than? Which one's showing me more change?
Oh my.
This is a bear trap. I don't know if Mr. Noel talks about bear traps. We talk about them all the time in my room. So this is what it's a problem. You think, oh well, 2 is obviously a greater number than negative 5, so we would have to pick 2. But that's completely wrong, guys. Because when we're talking about rate of change, we're talking about how quickly something's changing. So negative 5, right, as a rate of change compared with 2, it's actually changing quicker. So we would choose negative 5.
That is a bear trap.
Mm-hmm. Okay, compare the properties of these two linear functions. All right, so guys, we need to identify rate of change, also known as slope, and we need to identify the y-intercept, the initial value. Okay, I think we can easily do that from function 2. Right? Function 2 is an equation, so I know that this 2 right here, this is the rate of change. Rate of change. And I know that this number here, right, is the initial value. Okay, so we have a rate of change of 2 and initial value of 4. Not as easy to do on our table here, but we should be okay. Remember, if we're going to find rate of change, guys, we're going to do y minus y over x minus x. That hasn't changed. That's just slope. So I'm gonna pick out, here's one ordered pair. Here is the second ordered pair. If you need to write these, 2, 1, 5, 5.5, I want you to do that. Okay? There's nothing more frustrating than not getting a slope problem right just because we subtract in the wrong order or the wrong numbers. Okay? All right, so now we know y minus y. So this is 5.5 minus 1. X minus x. This is 5 minus 2. Okay? So this should turn into 4.5 over 3. All right, 4.5 over 3. Would you guys like to keep dividing that number? We can. That's 1.5.
It's 1.5.
Okay? All right. So function A has a rate of change of 1.5. All right. I got to get rid of some stuff here. All right. We just need to figure out now, guys, where does function A start? I don't know. Doesn't tell me. think about it this way.
Remember, for each x value, the y value goes up 1.5.
Yep.
So if the x value went down 1, the y value would go down 1.5.
So, in other words, guys, if we had a 0 here in our thing, like what number would go right here?
I know.
Right? That's what we're trying to figure out. So kind of look, as my x's keep dropping, getting smaller, what's happening to this number? Well, it keeps going down, right? This one has an initial value of -4. Guys, I think this one's going to be down there too.
Just to help, I mean, could we look this from 2 to 0 is a drop of 2, right?
2. So my x changes by 2.
Well, if I look over here, this is a drop of 2. From 11 to 9 is a drop of 2. How much does this drop?
By 3.
It drops by 3.
That same pattern's going to happen here.
What is 3 less than 1?
So if we go 1 minus 3, guys, what is that? Did somebody say -2? Did you hear it?
Negative.
Somebody
2.
said -2. So yes, guys. Right? So -2. All right, so there's our initial value. So this one has an initial value of -2. So now I can compare them. So which one has the greater rate of change? Function 2 has the greater rate of change, 2 compared to 1.5. Which function has the larger initial value? Function 1, right, has a greater initial value of -2 compared to -4.
Yes.
Okay. So there you go, guys. There is our examples for 3-3. We'll go ahead and we'll get into our key concepts. I will see you there.